Hello everyone, and welcome to our intro to Python video. Here we're going to be using Python 3, more specifically Python 3.7.1. I am going to be using the Spider IDE, that stands for Integrated Development Environment, and you guys can get that by getting the Anaconda software distribution. And here's where you can get it. So if you guys go to www.anaconda.com/distribution, you guys can get it here. And I'll be using the Spider distribution specifically. If you guys are interested in getting this, please download the Python 3.7 version. With that out of the way, let's get started. So the first thing that we'll cover is how to write print world in Python. And Python is quite human friendly compared to other languages like C and C++, and is generally used for prototyping software solutions. Typically, if you want to do something quick and dirty, you'd like to do it in Python. For a full implementation, a full software engineering solution, you typically would like to first prototype what you're doing in Python and then translate that to C++ or C, or any other language of your choice. Python is relatively slow compared to those languages, but Python uses a lot of environments that were built on C, and some of those are just as fast as C because it's just calling C functions under the hood. So first let's start with just a simple hello world function. So if we want to print, the function used for that is just print. Unlike other functions in different languages that may be printf or something of the like. So here we want to print hello world. If you want to run this program, you can save by typing Control S, and then you can run by typing F5 on your keyboard or going right here to the green arrow. We'll do that. So it'll run our file, and here's the output. Hello world. It's pretty great. So let's continue. So let's talk about numerical variables. What's a numerical variable? Well, it's just a variable that has a number as its data. Let's say x is equal to 14. Well, that's it. That's all we have to do. We don't need to do some int x14 like usual, like you would in C and C++. You don't have to do that. You just need to do x equals 14. You don't have to specify the data type of your variables anymore. And that's really, really nice. So now let's talk about something else. Why don't we use a floating point value like this? Same type of syntax. It's not too bad. If we want to print these variables, what we can do is I can say print x. I can put on a new print statement, print y. If I save and run, everything's printing pretty nicely. It's quite friendly in that regard. But what happens if I want to print x and y right next to each other? Well, something that I can do with a print statement is I can say x, and I can give in comma separated values. I say comma, and you know what? I want to separate it with the space, so I'll insert a space in between, and then a comma, and then a y. So here in this print statement, I'm going to be printing an integer with a character, and then along with a floating point value. And this is how I would go about that. It's quite simple. And here we have it. So here we have these two. Notice how the space in between it's a little bit extra. That's because by default in Python, when you have these as comma separated values, there's a separator variable that's included, and it's automatically a space. So all I have to do is just to put a comma in between variables that I want to print if I want to print them. Notice how now there's just a print variable there. So something that I can do is I can say separator equals, and I can change how things are separated. I can make things a comma if I wanted to. So let's run that. This is pretty nice. One thing that you might be realizing is that these print statements, they are ending with a new line, and that's because there's an optional end parameter that we can do here. So I can actually make a space for the end parameter of this print statement, and look how that changes. The end parameter is now space for the print statement on line 14, and for the print statement on line 15, the end is a new line. It's the same thing for line 16. So how do numbers interact with each other in Python? Well, it's much easier than you think. I can say z equals x plus y, and I can print z, and what'll happen is that it'll add them together without any problems. I can also divide numbers, and actually I can put those computations in Python. I can say 7 divided by 2. So this gets a little bit weird, because if you're a C++ programmer, one thing you're going to notice is that, hey, 7 and 2 are both integers, so it should be 3 instead of 3.5. But in Python, the single divisor actually does floating point division, and you'll see that with 3.5 right there. If I wanted to do integer division in Python, I'd actually need the double equals operator, and then it'll be 3, just like we'll see in C and C++. But here Python will try to make that implicit casting, which can be good or bad. Right? So with adding, multiplying, and subtracting numbers, the behavior is the same. It's only when we're dividing that the behavior is different. So if we use one single dividing symbol, it's going to do floating point division. If we use 2 division symbols, it's going to be doing integer division. One thing that's also nice is that the modulus operator is the same. However, using the modulus operator, they can only be used between integers, just like in C and C++. Something that's new being introduced into Python is we now have an exponentiation operator. Before in C and C++, if we wanted to exponentiate something, we'd have to create a function for that. Not for this. What I can do here is I can say 3 and I can square it. If I wanted to print that value now, I can do that as such. And this, look at the result. We have 9, as is expected. Right, so this is a really nice addition to Python. Now we don't have to write a function to exponentiate things. We can just use the asterisk twice. So this covers what's happening between numerical data. But what about letter-based data? Well, here in letter-based data, I'll say my string, I'll say s, not string, string is a keyword. String is equal to the string hello world, just as we had above here. We had our string hello world. And strings in Python can be double quotes, but they can also be single quotes. So I can say world here, give it an exclamation point, and we can reduce this. So we have hello world. These are both valid strings in Python, right? So if we compare to C and C++, characters are only enclosed in quotation marks, single quotation marks, like T is on line 25, but in Python, both of the statements on 24 and 25 are strings. So again, compared to C and C++, where strings are only in double quotes and characters are just in single quotes, they're all the same. Characters can be in double quotes and single quotes, and strings can be in double quotes and single quotes. The only operator that we can use with strings is the plus operator, which is similar to how it is in C++, where they concatenate each other. So let's print the result U. And concatenates the separate string hello, which was S, and the other string world, which was T. Concatenates them, it sticks them together. Doesn't matter if one variable is enclosed in single quotes and the other variable is enclosed in double quotes. This is pretty nice. So there's a lot of similarities between C and C++ in terms of interacting with numerical variables. However, Python introduces additional functionality, especially with the single divider, which does floating point division, and using the double division operator, which will do integer division. We also have a nice problem solved with the exponentiation operator, that being the two asterisks added to not only just integer operations, but floating point operations. Right, so this exponentiation is done on floating point operators, which is really, really cool. That'll be all for this video. In the next video, we'll be talking about valid variables in Python and Python keywords. Thank you.